Hello students, we are solving SC chapter 32 electric current in conductors questions, and student you can find out link of solution of all questions of this chapter below in description box. Student, we have also solved all questions of NCERT class 12 chapter 3 current electricity questions, so you can also find link of solution of all those NCERT questions below here in description box. And please, if any student is new on this channel, subscribe this channel and let us start our today's class. Student, question number 38. This question is saying a ball is projected from a point on the floor with a speed of 15 meter per second at an angle of 60 degree with the horizontal. Okay, situation is like this. A ball is projected with a speed 15 meter per second. Okay, at an angle of projection 60 degree, theta equals to 60 degree. Okay, now question is saying further, will it hit a vertical wall 5 meter away from the point of projection and perpendicular to the plane of projection without hitting the floor? Okay, there is a wall that is 5 meter away from this point of projection. Let this 5 meter away from this point of projection. There is a vertical wall. Okay. Will this ball hit this vertical wall which is present 5 meter away from this point of projection and perpendicular to this surface? Okay, let us check. Understand how will we solve this question and how will we think? This is important. Firstly, obviously, if we find out range of this projectile, range means how much horizontal distance it cover if it is projected with a speed 15 meter per second at an angle of 60 degree, then we can solve this question. So firstly, let us check its range which is given by u square sine 2 theta by g, where u is the speed of projection having value 15 meter per second, that is given. Theta is the angle of projection, its value is given 60 degree, and so when we solve it, 15 square sine 2 into 60 degree, 2 into 60 degree means this becomes sine 120 degree. G, its value is 10 meter per second square, roughly 15 square 225. This is root 3 by 2. Sine 120 degree, its value is root 3 by 2, and this is 10. And when you will solve, student, then its value becomes 19.45 meter. 19.45 meter. Student, you can think it means its value, its range is 19.45 meter. It means, suppose if there would be no any vertical wall, then this ball covers like this projectile motion, projectile path, and this length, this range, this is its range. Okay, but problem is that there is a vertical wall exactly 5 meter, just 5 meter away. So what will happen? Obviously it will hit this vertical wall. Okay, so the question is, will it hit a vertical wall? Obviously it will hit the vertical wall. You can see it here. Okay, student, now the question is further saying, will the answer differ if the wall is 22 meter away? Suppose if now for next part of this question, the question is saying if the wall would be at 22 meter away, the value of R we have calculated, its value is 19.45 meter. And now the question is saying for that suppose if the wall would be at a distance 22 meter, obviously 22 meter, this width greater than this distance. So let us suppose now the wall is now at this position, means this position is 22 meter. You can see it's very clear from the figure that now in this situation ball will not hit this vertical wall, and in fact this will fall on the ground before the vertical wall. It's very clear. So the question is saying, will the answer change? Yeah, obviously answer will change. Answer is changed. In first case it was hitting the ground, it was hitting the vertical wall, and in second case it is not hitting the vertical wall, so answer is changing. Okay, clear? Now we solve question number 39. Question number 39. Now this question is saying find the average velocity of a projectile between the instants it crosses half the maximum height. Okay, let us solve question number 39, student. Suppose a ball is projected like this. It is projected with a speed u. Its speed of projection is u at an angle of theta with the horizontal. Okay, a ball is projected with a speed u at an angle theta with the horizontal like this, and obviously its path will be like this. Case of a projectile motion, you can understand now. Now the question is asking that when it will be at half of its maximum height. What is its maximum height, student? This is its maximum height. We can represent it h. Just assume this is height h. So half of its maximum height. This ball will come half of its maximum height 2 times while going upward like this. When it will reach here, say it's a speed, it's something here, okay, and this height is h by 2, okay, and second exactly at the same level while going downward, okay, and again in this case its height will be h by 2. You can see it's very clear, okay, student. So suppose this point is A and this point is B. Now the question is asking to calculate the value of average velocity between A to B when ball will move from point A to point B. Then we have to find its average velocity. Student, it's very easy question. In fact, no need of pain to solve this question. How? Just think. You know, student, that during the projectile motion, its horizontal component of velocity, that is u cos theta, remain constant throughout the motion. Horizontal component remains constant throughout the motion. Why remain constant? Because there is no any acceleration in horizontal direction. And since there is no acceleration, obviously velocity will not change in that direction. And so that's why its horizontal component of velocity remains constant throughout the motion. Now, but its vertical component, obviously its vertical component changes. Why changes? Because an acceleration, that is your acceleration due to gravity, continuously acts in vertically downward direction, and due to this acceleration its vertical component of velocity changes. Okay. Now, student, you can also think that since these 2 points, or say in other words, while moving from point A to point B, its vertical component, magnitude of vertical component will remain same. If here the magnitude of vertical component, let obviously horizontal component will be what? U cos theta, since it will remain constant throughout the motion, okay, and let its vertical component at this point is x, okay. So here at point B, since this is at same level, same height from the ground, so from symmetricity you can say that its vertical component here will be also x, and obviously horizontal component will remain same u cos theta. Why the vertical component will remain same? This you can also understand in another way. In fact, what happens exactly? Vertical component is changing due to this acceleration due to gravity having constant value 10 meter per second square, roughly exactly 9.8 meter per second square. Okay, due to this acceleration due to gravity, this vertical component of velocity starts to decrease, because g is acting in downward direction, start to decreasing, okay, and finally when it reaches at its maximum height, then its vertical component of velocity becomes 0, and that's why at maximum height particle has only horizontal component of velocity u cos theta, okay. And again as soon as it moves right from this maximum height, again its vertical component of velocity, which was 0 at this maximum height, starts to increase with the same rate g, 9.8 meter per second square. With the same rate, this vertical component of velocity starts to increase, and so again after reaching the same height, it will again attain the same value of vertical component of velocity x as that was at this point. So you can also understand that the vertical component of velocity at the same level will remain same. Now finally we have to calculate average velocity. So you can understand that average velocity, which is obviously while you will calculate average velocity, then while calculating average velocity, this vertical component of velocity will be cancelled out. Why cancelled out? Because here same value in upward direction and same value in downward direction here, so this will be cancelled out. Finally only u cos theta horizontal component of velocity will contribute to calculate average velocity, and its value is constant. So now the situation is very simple. In one line the situation is that you have to find the average velocity if in horizontal direction a particle is moving with constant speed u cos theta, so obviously its average velocity will be also same, that is u cos theta. So this you can say this is the method 1. In fact you can also solve this question by another concept. Since the projectile motion, student, is an example of uniformly accelerated motion, and for uniformly accelerated motion, average velocity is what? Initial velocity plus final velocity. Let velocity at this point is vp and velocity at this point is vq. Sorry, let this is vb at point b and va at point this a. Okay, so average velocity is average of initial and final velocity, means va plus vb divided by 2. Okay, again va, you can write this va as u cos theta I plus xj, this is va. Okay, plus vb will be what? Vb, this is again u cos theta I minus xj, because vertical component is in downward direction, so we will take here minus sign, and here we have taken positive sign, and divided by 2. You can see here that this vertical component will be cancelled out, what I was saying in method 1. Okay, without writing, this is u cos theta I plus u cos theta I, this 2 will be cancelled out, and so this becomes u cos theta I, 2 u cos theta I divided by 2, 2 and 2 will be cancelled out, and so finally the value of average velocity becomes u cos theta I, means its magnitude is u cos theta. Okay student, so I hope you should have no any confusion. In fact you can also solve this question, student, by another method 3. If any student thinks that average velocity is also given by student displacement by time, we know it, displacement by time. Okay, no problem. Just suppose we can also solve this question by using this formula, by this lesson. Just see how. Suppose time taken by a particle to move from point A to point B is delta t. This is delta t. Okay, now average velocity. Student, it's very now clear that vertical component of velocity, it will have no any contribution while calculating average velocity. So now if you draw the graph of velocity versus time, velocity of x component divided by versus time, then since it x component of velocity u cos theta remain constant with time, its value is u cos theta remain constant with time, and let this time is delta t. So this is your displacement, and its area is displacement. This is your u cos theta into delta t, this is your area and this is your displacement. Concept should be clear, don't be confused. There is no displacement in vertical direction. In vertical direction there is no displacement when particle moves from point A to point B. This again comes on the same level, so no displacement in vertical direction, only displacement in horizontal direction. And so this is okay, displacement, final net displacement for calculating average velocity. And so average velocity was displacement. This is your displacement, u cos theta into delta t, u cos theta into delta t divided by time. What is time? What is time? Time taken is your delta t, and so again this will give you u cos theta. Okay student, so you can also solve this question in this way. I hope you should have no any confusion. So we meet in next class with solution of next questions. Thank you.